Hello students, today in this class we will be going to discuss about we are going to do a small derivation about to find the electric field due to a dipole on its axial line, equatorial line at any point. Okay, so what we are going to do, we are going to find the electric field. See, in the previous chapter we have found the electric field due to a point charge at any distance, say r, and we have computed that it is the electric field is equal to kq by r square, where k is what, 1 by 4 pi epsilon naught, right? Now we are moving one step ahead. Now we will consider, in place of one charge, we will consider two charges, like in a case of dipole. Okay, and at different positions we are going to get its electric field. Okay, so first of all, number one, axial line. This is very important for your exam point of view, so you need to study. Suppose here is a dipole. I'm making it bigger so that things could be clear. Here is a dipole. We are taking the measurements from the origin, and the origin is kept at the center. Now on the line joining this, if I produce this line so to form an axis, right, then this line is known as axial line. Okay, so now let us find out the electric field on its axial line at any position. Okay, at any position, but the position have to be on its axial line. Okay, we can choose here, we can choose here, even we can choose over here, right? For instance, let me choose here, and let's say this is point P, means here is a point we are interested to find the electric field. Let's say the origin is from O, so let's say this distance, as the texts have chosen, this is R. Okay, fine. Now at this point, electric field will be due to what? Minus q and plus q, right? Now due to minus q, what would be the distance of this? The total distance is how much for the dipole we take? 2a, right? Then if this is r, then we know that this have to be what? R plus a, while it need to be how much? R minus a, right? I think it's clear with it. Then what would be the total electric field here? Electric field at here will be due to minus q and due to plus q. Now what would be the direction of the electric field due to minus q? Direction of electric field due to what we'll do? We'll consider the field lines, right? Imagine a mouse over here. Down in what direction the mouse will go? That is a test charge. So this will be along here. This is, let's say this is E minus Q, electric field due to minus Q, right? Now due to plus Q, it will be in what direction? Repulsion, right? It is nearer, so electric field will be what? Bigger, right? Fine. But you will see that these two are oppositely directed but in a line, right? So what would be the total electric field? Electric field is a vector quantity, right? So we have to treat them vector in the form of vector, right? Then this will be what? E minus Q plus E what? Plus Q, right? Now I can assign this direction as positive, then the other direction have to be what? Negative, right? Right or not? So now as we are first finding the magnitude, so I'm removing it. Okay, now E minus Q, if I'm minus Q direction is how much? Is where? Along this direction, right? So this direction have to be what? Negative. Fine. So due to a point charge, electric field due to minus Q is what? K Q by what is the distance? This is what? R plus a square. See, k is 1 by 4 pi epsilon for air or vacuum. This is, I'm not writing again and again. Okay, then this direction is taken as positive, right? So this will be what? KQ by R minus a whole square. Now the rest is mathematics. Okay, so we'll do all the, what to say, KQ can be taken as common, right? Then this will be what? Minus 1 by R plus a whole square plus 1 by R minus a whole square. Let me quickly do this one. Then QK, right? Now if I take the LCM of it, this will be what? R plus a square, R minus a square, right? I may not have the proper space to do, so I'm going to shorten it up a little bit. Then this side will be what? This is minus R plus a square is already there. Then what it will be? R minus a whole square. Negative is already there. Then this will be what? R plus a whole square. I hope you are able to understand. Then E is equal to KQ. Now student, I'm jumping a little bit of step. A minus b whole square, a plus b whole square. Then minus minus. Then if you are going to do it, then this will be how much? Minus and minus. This will be what? 2RA plus here also 2RA. Do it by yourself. Okay. Then this is a plus b, a minus b. That is what? A square minus b square. Then over here square is there. So what it will be? R square minus a square. And there is what? Square is there. Right? Then this is equal to KQ into 4RA by R square minus a square. Now little bit of let me set a bit. A Q into 2R into 2A into R by R square minus a square. Can I write the same thing this way? Right or not? Right? Okay. Then what this is? E is equal to Q into 2A is what? Dipole moment, right? So this will be what? K P, right? Into 2R divided by R square minus a square whole square, right or not? 2R P K. Now K is what? Now let me write a bit in a problem. K is what? 1 by 4 pi epsilon naught, right? 2PR. In the text you will see in this form, R square minus a square whole square, right? Okay. Now this is disturbing me. Now see, this formula, I'm calling it as a formula. This formula shows what? The magnitude of electric field which is obtained at the distance r from the origin, right? So this is the constant of twice the distance into the dipole moment divided by r square minus a square a square. Now how to write in terms of vector, in terms of the vector form? Then this is what? E is equal to, now 1 by 4 pi epsilon is a scalar quantity. After all, it's a number, 9 into 10 to the power 9. Now 2 P is a vector quantity, right? R, then R square minus a square whole square. So what? The direction of E is along the direction of the dipole. This is important point to note. The direction of electric field due to the dipole on the axial line is same as that of the direction of the dipole. We can even see what is the direction of the net field here. The direction of net field is in this direction, right? And what is the direction of the dipole also? That is also in this direction. That means what? We can call they are parallel to one another. Thank you.